Right, people online. Uh, not muted, sharing my screen. If anyone's watching on YouTube, there is a quiz. Please go do the quiz. So, okay, so we have those functions, and then we want to be able to use those functions from use myString, and we also want to be able to use the structure that we created. So two things that we hadn't gotten to last time were if I want to be able to use functions like myString create, I need to actually also have the signatures of the functions be inside mystr.h. I'll explain why in a second. So basically what I want to do is I want to take the signature here and move it over here. So for example, it's going to be here. Don't forget the semicolon. So I'll take this and I'll move it here. And then I'll take the destroy one and I'll move it over here. And now this should compile with one small subtlety. So the reason it's like that is that in C, before you get to use the function, so for example, before using myString create, the function needs to be declared. So declare in the context of C means you give it the signature for the function. It's not necessarily the case that you already told it what is the implementation, but you told it the signature. And what does it mean before? Well, like it should be like literally before. So the way it works here is the include mystr.h includes this. So that means that it's as if this is copy and pasted, which means that the signatures are available before you use any of the functions in use myString. So the reason this has not come up before is we were generally programming top down. So we were making the functions up top, and then the main function was kind of like at the bottom of the file, and it was using the functions up top. So it hasn't come up. It was always the case that if you put the main function first, and then you define the functions that you're trying to use in main, that would not compile. It's just that it hasn't come up. When you're doing multi-file functions, then programs, then it's kind of that you got to do it this way. So now the way you can compile it, but I encourage you not to because that's bad practice, is you can just go to the folder and you can say gcc and then mystr.c, use mystr.c. That is fine. So that compiled. The reason it compiled is the main is over here. So in the main is where, hello, new people, please do the quiz. So it's not conceptually a difficult quiz. Just kind of going up to the midterm. So the midterm might be more difficult. So okay. So I have my main function here, and I gave it to GCC, and I also have my string C, so that's the implementations, and I compiled everything. So one important note, so some people often include stuff that's like not .h, they include .c. As far as C is concerned, like the extensions .h, .c, that's for you, that's not for GCC. GCC doesn't care about file extensions. You tell it to include, it includes. It's just that it's like not good practice to do it. So the good practice is you include .h, and then if you want to compile C files, then you directly tell GCC, I want to compile this C file. It can work, just like if you set it up right, it can work that you would say here something like include mystr.c. It can work because all it does is it basically says, well, not like this, but all it does is it basically takes the contents of mystr.c and just pastes them right there. Why not? You could do it. It's just that if you have more than 2 files, you are not allowed to include the same code twice and give it to GCC, because when GCC sees a function that's defined for the second time, it'll say, well, you already defined this, that's not allowed. You cannot redefine functions in C, unlike in Python, for example, where you can. In C, you can't, so that will just be an error. Now, again, you can like do a header guard on mystring.c and kind of maybe get away with it, but it's not good practice to do it. Don't do it. So just include the H, not because like, it's not like, the way I'm phrasing it almost sounds like it's a superstition. It's like, you know, like a bad sign if you do it. And that's exactly what it is, right? It's like the mechanism is not supernatural. It's that it's easy to mess things up if you start including C files. On the other hand, it's possible not to, but it's easy to mess up. On the other hand, if you just include .h files, and in your .h files, you just have definitions of structures and function signatures as opposed to function implementations, then that is usually fine. Okay, so yeah, like in a way, kind of, it's a guideline rather than a rule. It's a kind of superstition, but you know, like sometimes superstitions work. So for example, my office door, it used to be, now it's fixed, but it used to be that I noticed that I could always swipe in with my right hand, but never with my left hand. And took me a couple of seconds to realize, well, it's not actually because of magic. It's because of the angle, presumably, in which I'm swiping. But, you know, yes.
If you include all the code for those 3 functions in the H file, will it return an error?
If I include,
The actual code.
if I do include mystring.c.
Yeah, if you put the code for all the definitions.
Yeah, you could. You could. So where there would be an error. So if you both say include, so not over here, obviously, but if you over here you say include mystring.c and you also try to do this, that will be a problem, because this is like you're pasting the contents of mystring C into use mystring, and then you're also separately giving mystring.c to GCC. So that way GCC sees the code from mystring.c twice. So that's an error. Does that make sense?
Well, I was wondering, I was talking with mystring.h.
Okay.
And let's say you took the code from mystring.c and put it in those 3 functions over there.
Oh, that's exactly the same. I understand that it's a different question, but the answer is exactly the same. So the problem becomes, slightly different. Basically, the problem is it should be the case that any file from which you use those functions has those declared before the functions are used. And it also must be the case that a function is not defined twice. So if you just have two files, that can be fine. If you have multiple files and from multiple files, you try to include this .h, that can create a problem. And the reason is one way it could go wrong is the function definitions are still not there, but you already need to use them, or they get defined twice if you don't have the header guard. So again, it can work, but it's tricky.
So you don't actually define the functions in MyString.h in case there are multiple files.
Well, like part of it is convention. You can make it work, but the convention is this is just the signatures, and then the implementations are in a different file. Another reason to do that, we'll see later, is maybe I want to have a header file, and then I want to have two different implementations, and at compile time, I want to decide which implementation to use. Right? So I have like two versions of MyString.c. They both have the same signatures, but they're different implementation. So that's kind of another reason. Yeah.
Yeah. So it's more of a best practice thing. So if you have the methods in like another mention.h file, where will you put the declaration? You put it in that.h file, or you put it in MyString.h?
So the declaration, so this would be the declaration. The definition is the implementation. So the declarations go in the .h.
Like say if we have two .h files, but the functions are in another .h file.
Well, I mean, you could have multiple. Like in general, the functions should be in a C file. It's a very usual thing to have multiple H files. So you could just have like, those kinds of functions are in this H file, those kinds of are in another H file. Does that answer your question?
No, I'll think about this.
Okay. Yeah. Well, maybe I need to think about it. But yeah.
Why do we include MyString.h in both MyString.c and use MyString.c?
So you don't. So here, MyString.h, MyString.c, sorry, relies on there being a type MyString. That's defined in MyString.h. Make sense? So okay. So anyway, so that's kind of long story short. Declarations and definitions of types go in .h, include a header guard. Implementations go in .c. Okay. So that we do not do. You can compile things this way and, run them as well. So whatever. So now I have my program, use MyString, and I can run it like this. I encourage you not to do this, even though kind of this is like the easy path, like if you have 20 seconds. It's possible and not that difficult to set up VS Code so that you can use the run button. So the reason you cannot use the run button out of the box is the run button means compile the current file. You cannot just compile use MyString.c because that will mean that you're doing something like this. And if you do something like this, it'll say, well, there's no MyString destroyed that has been defined, so that's not a complete program. And the run button, that's what it does, is it compiles the one file that you're viewing currently. So, yeah.
So, like here, I'm noticing you haven't included MyString.c. So, is it because...
Well, that's for the purpose of like showing that would not work.
Okay.
Right?
So if you write include, then and you press the run button, it would compile those?
Like include MyString.c here.
Yeah.
I mean, yes, but that's not good practice. Okay, so what you want to do is you want to go to configure tasks. So for most of you, this would be GCC. It might read Clang. And over here is basically instructions for what it means to debug the file. So here, what it's saying is run GCC with like whatever color settings, I don't know. So G include the line numbers for example, Valgrind. And this is saying the current file. So what you want to do instead is you want to say not just the current file, but use my string C and my string C. So the most kind of general thing is to say, okay, so this is the folder where everything is. And here I'll say folder and I'll say mystring.c. And I'll say folder and I'll say use mystring.c. Okay, so that will make it so that when you press run or when you do run debug, it'll compile and it'll tell it the program consists of mystring.c and use mystring.c. You do not need to include .h because in this thing, because .h is included using #include. All right. So now that that's done, so again, terminal configure tasks. If terminal configure tasks doesn't work for some reason, you can also access it via tasks.json over here. So if you don't see it, remember that you need to open the folder in which we stored mystring.c, use mystring.c. All right. So, okay. So if I run this now, that is now fine. So the advantage of doing this is, yes. So it's the other way, right? So mystring.c includes mystring.h. So mystring.h is never compiled independently. What we're doing is we're saying, well, like for this definition, for mystring to create to even make sense, I need to have the mystring type defined. And that's defined over here. So include makes it so that this whole thing is basically copy pasted over here. So now my string is defined. Yeah.
I didn't really understand why you add the function like names in mystring.h.
So that's because a function before it's used needs to be at least declared, if not defined. So declare means that you include the signature. So in use mystring, we are saying mystring create. So if mystring create wasn't declared, so a signature wasn't in the program before, signature means the first line. If it wasn't before we started using mystring create, it would just not compile. So the way we're including it is we're saying include mystring h, which copy and pastes those declarations, and then you get to use it.
And so do you declare it twice?
Well, so you can declare as so here it's like a matter of terminology. So declare means include the signature. Define means actually give the contents. So you can only define the thing once, but you can declare it as many times as you like, as long as it's the same. Okay. Other questions? All right. But yeah, so those are kind of so, and I haven't mentioned the words linker, which would be relevant here. So I don't want to get too much in the weeds. I just want you to kind of follow the structure. The structure is declarations, structures in the H file, and then the implementation of the general purpose functions in another file, and then you can use those functions in a different file if you want a multi-file program. That's all there is to it. All right. So the reason I was setting up VS Code is that now I can have breakpoints and stuff, right? So I can put a breakpoint over here, and I can run it, and now I'm here, and I can look at like the value of S and stuff. Well, it's not defined yet, but once it's created, now str contains ANSI and stuff, so that's nice, and I can debug. That would not be possible if I was just using GCC. So I showed you how to use GCC. I think some of the TAs might sometimes show people, or like whatever, I'll just do the GCC. It's good in the very short term. For the next 30 seconds, you're happy it compiled. For the next several hours, maybe you're not happy because it doesn't work and you don't know how to debug it. So it's better to set up VS Code. It's really not that difficult, and we'll make you do it next week in the lab. So hopefully you get used to it. All right, other questions? Okay. Yeah.
So if you don't do the tasks thing, you can still compile both.
So you can compile with GCC. You cannot compile. You cannot compile this file because it doesn't have a main function. So you cannot compile this one independently, and you cannot compile this one independently because it uses functions that are not actually defined.
You compile it together and in the terminal.
So just GCC, and then the name of the file. So you can list as many as you want.
Okay.
And that's in fact what we did in tasks.json, right? As we said, this is the GCC, and then like whatever settings, and then we just said like compile this guy and compile this guy together. All right, makes sense? So, okay. Other questions about this? All right, so that's basically also the structure that you're going to be using in project one, right? So in project one, you have your main file, and that's where the functions that you define are used. And then you have the other file where you're actually defining stuff. So this is also convenient for us because you just submit the file without the main function to Gradescope, and that's because we have our own main function that tests your code. And like in principle, it's like not that difficult to actually, we have done it actually for online exercise 1. We just like removed everyone's main function so that it doesn't interfere with our testing. It's not that difficult to do. You can do it in Python. We did it in Python. Yeah, so kind of when you submit, just submit the functions, not the main function. I think when you're debugging, it kind of makes sense for a smallish program to include the main function when you're testing and to then get rid of it when you're submitting. Just because like when it's one file, it's like easier to deal with the testing. That doesn't really matter. If you set it up like that, it literally takes 5 seconds once you get the hang of it. And then you can debug the multi-file program as well. All right. Yes.
So just be clear, the better practice is doing that or using the GCC command.
So I would say, so if you want to debug, which you really should want to do, then doing this is the only way. You cannot debug using the debugger if you compile with GCC. I should say, like in the background, it of course still is compiling with GCC, right? So, yeah. Okay, all right. So I want to do another example. So that's the example from last year's midterm, which like some people were not fans of, but nevertheless. So what I want to do is I want to do something like, so far we were doing like strings, and that might seem like, why are you doing this anyway? So I'm going to do Python 3 integers. So just kind of to remind people, just like floats in Python 3, integers in C are not unlimited. So you have a limited number of digits that you can store. So for example, so I'll just define an integer and I'll keep multiplying by 10. So I'll say like while and I'll print n. And I'll multiply it by 2 or something. So here's what's going to happen. That is not what I intended. So this is underlined because it still doesn't see that I did include stdio.h. So run it. Does anyone see the problem? I don't see the problem. Okay, now it's stuck as well. Oh, I do know the problem. Okay, so it's actually working, just not in the way that I anticipated. So okay, that's just the old version. Okay, I need to restart. So the point is, there's gonna be a good part very soon, by the way. So the point is that at some point, the n will stop growing. And that's going to happen very soon because exponential growth is quite fast. So what you saw here is it became negative. So the reason it became negative is because the way it works is you get to the largest possible int, and then you just wrap around to the smallest possible int. So it'll just go around in circles like that. So the reason you saw the zeros there is that it eventually got it wrapped around and it got to a 0 somehow. And then, of course, like once it's 0, it's 0. All right, so the details of how it's represented are for a later lecture. So today, what I want to do is kind of a prelude to that, which is I want to implement an integer that doesn't behave this way. Okay, so I want to have infinite digits. So here's my plan. I already have infinite strings. So I have strings that can store as many characters as possible. So what I'll do is I'll use those strings in order to store the integers. Right? And then if I run out of digits in the string, well, I'll just resize it. So I also want to be able to perform various operations on the string, on the integers, sorry. So for example, I want to be able to add them. So how do you add two integers? Well, if you have two integers, like for example, you want to say like 1, 2, 3 plus 7, 8, 9. What you do is kind of like the grade school algorithm, right? So you say, okay, so 3 plus 9 would be 12. So this is 2, and we carry the 1. And then 8 plus 2 is 10, but we carry a 1, so that's 11. So that's a 1 over here. Sorry. And we again carry a 1. So this is 8 plus 1, so that's 9. Is everyone good with this? Who is not good with this? All right, so again, kind of the algorithm is we add digit by digit, except sometimes there is a carry, right? So if you say 3 plus 9, then that's 12. So that means that you write down the 2 over here and you carry the 1, right? So then you add all of those. So this is 1 plus 3 plus 9. So that's 11. So that's 1. And again, you carry the 1 over here. And this is 1 plus 1 plus 7. So that's 9. And that's it. Make sense? So, all right. So one kind of issue is suppose this were a 9 rather than a 7. So then you would have 1 plus 1 plus 9, and that would be 10. So that means that over here, you'd write it as 10, 12. Make sense? So, okay. So for that reason, it would be more convenient because I might like to add a digit at the end to do things in reverse order. So rather than write 1, 2, 3, I'll write 3, 2, 1 rather than write 9. Well, 9, 8, 9 is symmetric, so that's convenient. So then what I'll do is I'll just say, okay, like 3 plus 9 over here, that's again 2, carry the 1, 2 plus 8, carry the 1, 11, and then 1 plus 9, that's 10, so that would be 10 like this. And that's convenient because I need to add digits to the end rather than to the beginning. Does that make sense? So, all right. So I'll define my So I'll define my pi int. So that's my header guard. So that would be a struct that's way too difficult. So what should we have in this struct? So basically the same kind of thing, right? So it's gonna be a bunch of digits. So I'll name this buffer. And there's gonna be a length. So while we're in the H file, what kind of things would we need? Again, we would need to be able to create the pi int. And let's say that that's always just going to be a 0 initially. We would need to be able to destroy it. And we would want to be able to set it short. And so here, of course, like you only are able to give an integer as the value, but in principle, it could go beyond the value of what's possible in a single integer. And I want to be able to get it, sure. Let me do it. Let me just do print. Oh, print we already have. No. Like this. And I want to be able to print to add. So now let's go about actually implementing this. So I'll copy and paste this into pyend.c. And I'll open my pyend folder. So in many ways, that's going to be the same thing, right? Where what I'm doing is stuff that's very similar to create string. So in create pyend, I'm taking a pointer to pyend, and I'm taking the length. And what I'm going to do is I'm going to say there's going to be a block of digits here. So here, this would be a block of this many digits. I stored the length anyway, so I don't have a special 0 or anything. And I stored the length over here. All right, so again, I'm passing the pointer p. So that means that I can change the contents of whatever is the object, the address of which I passed, right? So p is the address of the pyend object. This is going into the pyend object and saying the length is going to be set to this, and then the buffer is going to be set to this. Make sense? So I want to make it be not kind of not just random. So I think what I'll do is I'll set all the digits to 0. So one way to do it is with calloc. Another way to do it is with memset. I will, in this case, choose to just do a loop. So I'll just say, okay, let me type it because probably some people are typing. I'll just say everything is 0, and that makes it so that all the digits are 0. Make sense? Yeah. Yeah, I could use calloc or I could use memset, yeah. So, yeah, so something like this, or I can use memset, and that's like this. So memset just gets a pointer, and then I'm saying set set every byte to 0, and it's this many bytes. Yeah.
I noticed you didn't have like the get value function.
Well, yeah, because where would you put it in? Like, it wouldn't fit into int.
Right.
So you can print. But yeah, like you could say, like, and I kind of momentarily also thought, like, why don't we do a get value? And then I thought, oh, well, like, actually, in general, it would not fit into any particular value that's not a pi int. So in a way, like, how would you get the value? Well, like, that's the value right there. You can print it, however. All right. So let's do a set pi int. So that's so we did examples like that, but it's not kind of completely straightforward. So what's going on here? So the value is, let's say, whatever, 567 or like 190. So that means that the buffer would be not that, so 091, because we're storing it in reverse order. Right? So I want to get 0 and then 9 and then 1. This is actually like the most straightforward situation where you just do mod 10 divided by 10 every time. Okay. So here we say int I, and then we say, oh, we could do it like that, I suppose. But I'll just assume, should we assume? Let's not assume that. So let's say that we need to actually, that like if the length is not enough, we'll realloc as we go. Right? So I'll say, yeah.
But the value that we're setting is an int, right? So it's nothing that it's going to fit.
Well, no, because the length is the number of digits. Right? So the length is the number of digits in this buffer, and that could be quite small. So we'll say, okay, so while value is greater than 0, so what do we do? So we say, okay, so p buffer I is value mod 10. So get me the last digit in value and put it in the current position in the buffer. And then divide value by 10. And then increment I by 1. So the problem can arise when we're saying p buffer I, but I is too large and cannot be contained in the buffer. So what we should do is we should say, okay, so if I is greater or equal than p length, then there is no space. So here it suggests printing an error, but that's the. Why is it freezing like 2 minutes before the end of lecture every time? So it did freeze. So we'll continue next time. But yeah, that's like a timer on it. That's really weird. So what we're gonna do is we're going to realloc the buffer so that it's longer, so that you can put p buffer I value mod 10 into p buffer I. So I will use the board for the 1 minute that's left. So if I have 190, so that's the value. And I have I, so that's 0. So value mod 10 so value mod 10 is 0 initially, and I put 0 in the buffer. Right? And then I do value divide 10, that removes this stuff. So then I do value mod 10 again. That's 9. So I put 9 over here. Do value divide 10, that's done. Value mod 10 is 1. I do value divide 10 again, value is now 0, and then I'm done. Yes.
So the way you're doing it is you're having only 1 digit per int. So-
Yeah.
Okay, so a 5-digit number would have 5 intel.
Correct. Correct. Yeah, so I could make them cars or something so that they're smaller, but like not as fun.
Inside it.
All right, okay. I shall see you Monday. Bye.
Like in the, I saw the recent question last last time.
Yeah.
It's the same with the question five.
Yes.
And so like for the question five, in the midterm, the solution is that we should use double pointer when we are creating the pi n.
I don't really remember what the question was asking exactly.
So-
And my computer is frozen.
Okay.
So
So the only difference that when we're using like create pi n,
Right.
you are passing like a pi only one single pointer into it, but the solution has double pointer into it.
so I don't remember, or like, if you want to show me the solution to your computer, I don't remember why. So this certainly works.
I mean like